Dear students, have a great day to all of you. Today also you have gathered here with our new video launched by SL Argentum YouTube channel. So today we are meeting after a few videos. So your O-level examination is very closer with you right now. So you should know how to use this remaining days, how to use the remaining days very properly by managing your time without wasting at least 1 hour. So it's very important for you, my dear children. So that's why today I decided to do a special question for you, and this is target question. We are expecting this question will come to your O-level examination, this kind of a question. So that's what we selected this question for you. So hope all of you will join with us, and please concentrate with the video very properly without thinking any other things. I'm sure when the video is over you will get the maximum benefit of that. So to do that you should pay your full attention with the past paper book, and you should analyze the question. You should give the proper idea for me regarding this question by writing a proper answer to the O-level paper. So you should know how to do that. So please be attentive with the lesson and please be supportive with the lesson. So hope all of you will join with us, and please subscribe our YouTube channel and share these videos with your friends. So children, let's start. Okay children, so take 2017 O-level paper. This question is mainly based on electrochemistry part. So as you all know, when you analyze past paper questions, children, mainly lots of marks are allocated for this kind of a question. So that's what you should aware how to write a proper answer for this question in a specific way, right? So that's what I selected this question, my dear children. So take 2017 O-level paper essay question part B, right? 2017 essay question part B. What's the question number? Sixth question part B, right? So as I mentioned previously, take the past paper book. I think sometimes you have done this question, whether you have not done this question, whatever, right? You should pay your full attention. Then you should know what are the theory parts and what are the major important things to be followed in this video. Well, right, okay. So can you see here, my dear children, two cells are given for you. In the following figures, two cells are given as A and B, right? One cell, it is known as capital A, other one is known as capital B. From the above two cells A and B, which is the electrolytic cell. So children, electrolytic means, right? Actually children, there are two ways of this electrochemistry lesson. First I'll explain that for you, right? Okay, now listen. Right, one is children producing electricity or current with solution, right? For your awareness, I have divided that, right? One is that. So can you see capital A? That is based on this, right? I'll explain one by one, no problem. Second one is, right, changing the solution with electricity, right? So what did I tell here, right? You will be explained further hereafter, right, how we can classify the major cells in the question according to these two. Well, okay. Now children, please see the first one. You can see here in first cell, it is known as capital A. Zinc electrode and iron electrode is inside there, and diluted sulfuric acid is also there, and both are connected with connected wires. So as you all know children, if you can connect a bulb or an ammeter, what can you see here? If you can see the ammeter, you can see the indicator of the ammeter is rotated, right? That's the first observation you should know. If you have connected a bulb with a low light, you can see it is lighted up, right? So those are the observations you can see. And you can see here gas bubbles are liberated near iron electrode, right? and B is another one, right? So it's better, children, I will explain for you one by one respectively, one by one each way, right? So second one is known as, B1 is known as electrolytic cell. Why? This kind of a thing is happened in B, like this, changing the solution with electricity. Can you see in second part in B, batteries are connected, isn't it? Yes. So with the batteries, with the electricity, something should be happened inside the solution. So that thing is mainly happen regarding this, according to this one. So let's see how we can do that in proper way, right? Now see the first one, it is capital A, right? So children, basically I'll explain the theories here, right? So if you are not aware, please put a message or a comment for me, right? For your further awareness, right? Now see the board. I'll take the example that you are given in the question, my dear children, right? It's like this, no? A container is there, maybe it is a beaker, right? So a beaker is there like this, right? And one rod is a sink rod, isn't it? Is that a sink? Yes, sink rod, right? It is a sink rod, and other one is an iron rod. It should be the same size, and both are connected with a connective wires, right? So children, remember, commonly we can tell for both, right? Now this should be sink, right? This should be iron, no? Right? So commonly we can tell this sink as an electrode, right? Not electron, electrode. So this is also can be identified as electrode. So actually what are these electrodes, children? It's a rod, right? It's a rod, right? So here sink rod, it can be identified as sink electrode, right? This is also another rod, right? So this can be identified as iron electrode. So remember, what are electrodes actually? The rods, right? So maybe it is a sink. Sometimes you can see here, instead of iron, you can see here copper rod. Same observations are happen, right? Copper rod. So that time also you can identify copper rod as what? An electrode, right? So electrode is a common word, my dear children, right? Electrode is a common word. So you can identify, right, these zinc and iron respectively, right, as electrodes here, right? And the solution is inside there, right? The solution is inside there. They have mentioned, right, that solution is dilute sulfuric acid, right? Dilute sulfuric acid. Children, I have a question from you to ask. What are the things you know about sulfuric? Once you see sulfuric, right? Once you see sulfuric, whenever it is in O-level examination paper or term test paper, school semester exam paper, or maybe when you are doing at least a question or something, once you see sulfuric, children, you should remember something. My question is, what you should remember when you see sulfuric? I have told you, sulfuric is the most powerful acid in our school lab, isn't it? Now, normally we know there are three powerful acids in our school lab. One is sulfuric, one is hydrochloric, other one is nitric. So, if when we consider among those three, actually children, sulfuric is known as the most powerful one, right? Why? Do you know what is an acid? What is an acid? Acid can release H plus ions very properly, right? Acids can release H plus ions very properly. But remember, some acids are there, they can't release H plus ions very well rather than powerful acids. So those are known as weak acids. These are known as H2SO4, HCl, HNO3. What is H2SO4? Sulfuric. What is HCl? Hydrochloric. What is HNO3? Nitric. All are known as the powerful acids in our school lab. Those are known as strong acids, right? Strong acids. So children, here we are using diluted one, right? Diluted means we should add water. Why we are adding why we are adding water there? Because you know, sulfuric or whatever the acid, they can show their powerfulness, they can show their talents actually when they are mixed with water, isn't it? You have heard the definition what is an acid, right? Acid means, right? Acid means a chemical substance which can release H plus ions when it is mixed with water. So children, if you can identify, if you need to identify H plus in whatever the kind of an acid, it should be definitely mixed with water. So that is known as dilute sulfuric. Understand, my dear children? Okay, that is dilute sulfuric, right? So once you see dilute sulfuric, you should have an ability to write this one, because you should know, right? What? H2SO4 AQ. Children, why I put AQ here? It's a physical state, right? It's a physical state. We should put AQ. Why? To show that what? To show that it is a diluted solution. Water is mixed with that. To show that we are putting here AQ, right? What happens? H plus ions are released, and finally sulfate ions are already remaining inside the solution. H2SO4 H plus plus sulfate ion. But children, still I have a problem to ask from you. This equation is not balanced. I'm not satisfied with this. Why? Can you please tell why this equation is not balanced as I mentioned for you? That's a little problem, isn't it? Can you see here H2SO4? Here there are two hydrogens, but in this side only one H plus is there. That should not be happen. So you should put 2 in front of H plus. Then the equation is almost balanced, right? Remember, you are given full of marks when you write the balanced equations. So if that equation belongs to this kind of a lesson, definitely you should put the physical state of each reactants and each results respectively. Otherwise, you are not given full marks. Understand? Okay, very well. Right. So you should know. Right. Now, children, can you please remember? Now you have already settled these apparatus, right? You have taken a beaker, right? You have put their dilute sulfuric inside there, and you have taken zinc rod, you have taken iron rod, and you have put them inside there, and you have connected it with a wire, right? So children, now that this is not mentioned inside your book, but for your awareness, I will draw an ammeter here, right? Okay, this is the circuit symbol of ammeter, right? So you know, if the indicator of the ammeter is rotated, right, we can see a current flows there, right? That's what. Okay, now let's see, right, what is going on here. Now children, what are the observations you can see after doing this apparatus, after doing this practical? First one, right? First I'll explain the observations, children. Then let's discuss what are the reasons for those observations we identified. Okay, well, one observation is, now we have already settled this apparatus and we are looking for that, what is going on there, right? One observation is, you can see here gas bubbles are liberated. What do I mean by liberated? Released. Gas bubbles are liberated from or near, you can write from or near the iron rod or iron electrode, right? That is the first observation you should know. Gas bubbles are liberated or gas bubbles are released from where, children? From where? Here, from here, right? So I'll draw like that, like this. So still we don't know what are those gas bubbles, right? So if you have done this very properly, you should know it is hydrogen gas bubbles, isn't it, right? But now we are trying to solve this step by step now. So that's what, now we don't know what are the gas bubbles liberated near here. That's the first one, right? And you can see ammeter indicator of ammeter, right? So that is not in your O-level past paper book, but I drew here for your further awareness. You can see what happens. It is rotated. That means in this cell, what should be generated? A current. Because of that current, you have seen the indicator of the ammeter was rotated, something was happened, right? Okay, let's see. Right, so those are the observations, my dear children. Right, now let's discuss what are the reasons for these observations. Now see your attention properly. Right, okay, now my dear children, see the board. Right, now what was our first observation? Other one, I forgot that. Right, my goodness, the first observation, zinc electrode was dissolved. What? Yes, zinc electrode was dissolved. That was the first observation, right? Sorry for that, I forgot it. Right, that was the first one. Right, so what are the three observations we are aware right now? First one is zinc electrode was dissolved. Second one is gas bubbles are liberated near where? Iron electrode. What is that gas? We don't know yet. Well, third one is, you can see here, the indicator of the ammeter is rotated. It means current flows through that. Understand? Those are the three observations you should know. Now let's analyze what are the reasons for those three observations in this cell. Well, okay. First, we are coming here to identify how the zinc electrode was dissolved. Okay. Right. So the space of the whiteboard is not enough. That's what I have written here near this one. H2SO4, that is dissolved for 2H plus AQ and SO4 2 minus AQ. Right. Now listen carefully. Right. This is the explanation. Right. Children, you can see here this zinc electrode. Right. Zinc electrode, you can see. Right, I think you have copied down this one, children, right? Because as I told you, when you are doing the past papers with me, it's better if you can have a just kind of a piece of papers or a separated book for this, because I'm mentioning some kind of special theories for you. So you can take red pen, blue pen, black pen and highlights pens as well and write the important things you have notified through this video. Understand? Okay, right. Right. So children, what was the first observation I have told you? What was the first observation? The first observation was zinc rod. What happened? Dissolved. Right. Now let's see what is the reason for dissolving zinc rod. Right. Now listen carefully. Now children, zinc is a metal. No, zinc is a metal. Metal is actually what? A solid. Right. So can you remember the structure of the atoms of the solid? I can take you to grade 5, grade 6 science. Right. You can see here the atoms are arranged with the correct order, no any spaces between two atoms, right? So atoms are arranged very well like this, right? So zinc electrode, inside the zinc electrode, the atomic arrangement is also like this, right? Zinc atoms are arranged like this, right? Okay. But children, something is happened here. What? Now here, this part of the zinc electrode is already moved with what? This solution, dilute sulfuric acid. Children, when they are exposed to this dilute sulfuric acid inside the container, inside the beaker, they can't stay like, they can't stay as a solid state, right? They are trying to convert liquid state, right? But it's too much hard because this is a solid, this is a metal, right? So when they are trying to convert their atoms to liquid, they should make what? Iron, right? Otherwise they can't go here and there, right? So what they should do, children, zinc, I think you are not familiar with very much zinc because you are very aware that the first 20 elements of periodic table, but zinc is not in there, right? But children, remember, zinc is also like magnesium. Zinc is also like beryllium, right? So beryllium, magnesium, they are releasing how many electrons at once? Normally 2 electrons they are released and they are making 2 plus ions. Beryllium 2 plus, magnesium 2 plus, likewise, right? So zinc is also doing the same thing like them. So you are not familiar with zinc, children, but in this lesson you should know zinc is releasing 2 electrons to make zinc 2 plus ion, right? So can you explain this? Now you can do this, zinc 2 plus. Who can explain this? What do you mean by zinc 2 plus? Huh? What are things you know regarding zinc 2 plus? You can say with me, children. That is the way you are teaching. That's the way you are learning. That's what. Okay. So zinc 2 plus. Can you please tell what is the meaning of this zinc 2 plus? It is an ion. It is not an atom right now. It is an ion. What else? Huh? How many electrons are released here? 2 electrons. How did you tell 2 electrons were released? Huh? Because it is mentioned here 2. What do you mean by 2? 2 electrons are released. It is known as 2. What do you mean by plus? Plus. Plus means released, right? You know these things, right? In first lesson, first basic chemistry in grade 10, right? Released. To show released, we are taking the icon plus, right? So what is this? Chlorine minus. It should be chlorine 1 minus, but normally we are not putting 1, right? So what is the meaning of that? 1 means what? 1 means the number of electrons. How many electrons? 1. Normally we are not putting 1, right? But you should know if no one is there, it should be 1. What do you mean by this minus? Negative. It means electrons were gained, electrons were obtained, right? So you should remember, positive ions are always made after releasing electrons. Negative ions are always made after obtaining, after gaining electrons. Understand what I say? Okay, well, right? So children, zinc is making zinc 2 plus ions, right? Then what happens? Zinc atoms are making zinc 2 plus ions, and they are jumping to the solution like this. Jumping means they are adding to the solution zinc 2 plus, right? So what they are doing is zinc, it is a solid, right? It is a solid. Why zinc is a solid? Because children, zinc is a metal, no? Zinc is a metal. So metal is already a solid, but you should know one liquid metal is there in the world, right? That is known as what? Mercury, right? So apart from mercury, other every metals are mainly solids, right? So zinc is a solid metal first. What happened? Zinc converted to zinc 2 plus ion. Now ion is a solution. Why? They jump to solution after becoming as an ion. So that time it should be zinc 2 plus n. It should be what is the physical state of that? It should be AQ, right? So children, now can you please tell something? How zinc atom made zinc 2 plus ion? Can you explain? Yes. How zinc atom made zinc 2 plus ion? Yes. After releasing 2 electrons. How did you tell that once zinc removed 2 electrons? It is mentioned, no? Here 2 means the number of electrons which were released. How did you tell? Released plus, right? So how many electrons? 2. That should be mentioned like this, 2e, right? 2e, right? It is known as 2e. 2e means 2 electrons, right? So zinc, it is converted to zinc 2 plus, and how many electrons are released? 2 electrons. I have a problem. I have lots of problems. No, children. Every time I am asking, I have problem, I have problem, I have problem. So this time also I have problem to ask from you, right? Now, zinc converted to zinc iron, no, zinc 2 plus, right? So think zinc 2 plus iron jump to the solution, right? It was added to the solution like this, right? Then 2 electrons were released by one zinc atom, no? So what is happening to that 2 electrons? What happened to those 2 electrons? Will you think, are they also jump into the solution like zinc 2 plus? Children, what do you think? Now raise your hands those who are thinking like this. With zinc 2 plus ions, 2 electrons are also released to the solution, dilute sulfuric. Raise your hands those who agree with my statement. I can't see you. I'm thinking you will raise your hands. That's what you are learning. That's the way you are communicating with the teacher. Even this is a YouTube video, isn't it? Huh? What do you think, children? No. Right? These two electrons are not released to solution. Solution is never accepting electrons. So, solution are only accepting what? Ions. Electrons are not, right, formed, not added to solution. Then what happens? Electrons are kept inside the zinc electrode, right? So what are zinc doing? Zinc one atom is there. It is keeping two electrons in zinc electrode and they are converting to zinc 2 plus ions and they are adding to the solution. This process is occurred gradually. Lots of atoms are making ions and they are formed with the solution by keeping electrons inside the zinc rod. Then because of that situation, you can see gradually the zinc electrode was what? Dissolved, right? So this kind of much dissolvement you can't see, but you can identify very gradually the zinc electrode was dissolved. What is the reason? Reason is this, right? Reason is this, right? So that's the reason, right? So when lots of atoms were dissolved to ions, right, because of less atoms means, children, atoms were converted to zinc 2 plus means no atoms here right now. No, why? All were converted to ions and they added to the solution. Then no atoms means, right, can you see the entire zinc electrode here? No, that is dissolved gradually. But make sure electrons were not kept inside the solution. They are already, right, stored in zinc electrode like this. These are the electrons which were kept in zinc electrode. These are from whom? The zinc atoms, those who went to the solution. Right. Now what happens? Now this process is occurred for a long time now. Then children, electrons were overloaded there. Why? Lots of zinc atoms, they are releasing electrons and they are added to the solution, and the population of electrons here, right, the density of the electrons here is very much high right now. Then what happens? Zinc electrons were overloaded. Then electrons were shifted to the connective wire and it was transmitted from zinc electrode to iron electrode like this, right? The electrons are passing like this from where? Zinc electrode to copper electrode. Why electrons were transmitted? Because the density of the electrons were very high, because lots of zinc atoms converted to zinc 2 plus ions after being released electrons, right? So that's why, children, those electrons were shifted to the connective wire and it was transported to iron electron. Can you remember, my dear children, you did in current electricity lesson when you were in grade 10, you studied about what is the current, right? Actual current means what? Overflow of electrons, right? I'm not talking about the standard current, right? Actual current means the overflowing of electrons, the flowing of electrons. When these electrons are passing, when these electrons are transmitting from zinc to copper, because of these electrons, a current was generated. A current, right? Because of the movement, because of the flowing of these electrons from zinc to iron, what happens? A current was generated, my dear children. That is known as actual current, right? So you have studied in current electricity. Mainly actual current is generated because of the flowing movement of electrons, isn't it? Yes, right? So because of these electrons, a current was generated. Now I have a problem. Again, I have a problem, right? How did I tell a current was generated? Now you may tell like this. You saw the current? No, children. Then how can you tell a current was generated? Can you remember we wrote an observation the indicator of the ammeter was rotated. I saw when I was doing this practical, after being settled down everything, right? I saw the dissolvement of zinc electrode. That's okay, that was possible. Second time I saw when this was happened as usual, right? The indicator of the ammeter was rotated. Then I realized that this happened because of this. This happened means what? The ammeter indicator was moved. Indicator was rotated, right? So because of what? The electrons were passed through the ammeter. That time it was acted as a current. So a current was passed through the ammeter. As a reaction of that, what did ammeter do? Ammeter rotated its indicator. That's what the tally of the observation and the results we are doing in this experiment. Understand? Well, okay. Right, second one is also okay, right? Now come to the equations, right? Zinc 2 plus 2 electrons, right? That was the first one, first observation. Second observation, can you remember? I told you something. Gas bubbles are liberated near where? Near where? Near where? Near zinc or near iron? Near iron. Gas bubbles were liberated near iron. Then you should have a problem how it was occurred, how it was happened, how the gas bubbles were liberated near iron. Let's discuss how it is happened. Right, our next observation was gas bubbles were liberated, gas bubbles were released near where? Iron electrode. Right, now children, step by step let's solve this problem. Right, now what is inside the solution? Dilute sulfuric. Dilute sulfuric means what? The sulfuric which was mixed with water. Right, so inside the dilute sulfuric solution, these ions were contained. No, what are those ions? 2H plus and sulfate. Right, okay. I'll write this 2H plus. Always keep H plus as a couple because when they were dissociated, all were formed as couple, 2H plus, right? And sulfate, right? Now children, this H plus, they are positive ions, no? They are always looking for electrons. Why? Positive ions, they are looking for electrons because what? They need to keep what? It should be stated like gas or like a solid. So that's why these 2H plus are looking for electrons inside the solution, right? Children, please answer to my question. If these 2H plus are needed electrons, to where they should go? To zinc rod or to iron rod? To zinc electrode or to iron electrode? Please tell. I'll give you 10 seconds. Right? I'll repeat the question. If 2H plus, if these 2H plus are needed electrons, to which electrode they should go? Should they go to zinc electrode or should they go to iron electrode? Ions, these two should go to the place where electrons are fulfilled. Otherwise, no need to go. If they are going no electrons, then they should withdraw again. No problem, right? But if they can go to the place where electrons are almost fulfilled, they can easily take electrons and convert to gas. My question is, to where they should go? Now children, you can see here, zinc electrode is always releasing electrons and those electrons were transported from zinc to iron. Now electrons are with whom? Now electrons are with whom? With iron electrode. Whose electrons? Are they belongs to iron? No, no, no. Those were the electrons came from zinc. But now they are in where? Near iron electrode. They are belongs to zinc, but now they are in where? Near iron electrode. So to where 2H plus these couple should go to take electrons? Near to iron electrode, right? So children, what is happening there? 2H plus ions, they are taking 2 electrons and making H2 gas. This is the second one. They are making H2 gas. H2 is a gas, colorless gas, the light gas in atmosphere. So that's why we saw near with the iron electrode what was liberated, what was released? Gas bubbles. Now you should know what are those gas bubbles. What are the gas bubbles? What are those gas bubbles? Hydrogen. So actually what was the gas which was released near electrode? Hydrogen gas was liberated. Hydrogen gas was released, right? So, right, there's no way to collect the hydrogen gas here, but if we have the way to collect, right, we can take a splinter and we can see, we can hear the sound pop and it is being extinguished, right? So that's what, okay? So that is the way we can take the one, right? So we have taken two equations here with you right now. This is one, this is two, right? So a chemical equation is not completed with electrons, so we should remove these two electrons. What you should do, you have done in maths simultaneous equations. It's the way you should do that, right? So 1 and 2, what you should do is you should take the sum of 1 and 2, right? Please take this part separately and this part separately. It's up to you, right? It's up to you, right? So children, how we can do that? See the board. How you can do that? So take the summation of each one respectively, this side and this side. Zinc solid plus 2 H plus AQ plus 2 electrons arrow. This side zinc 2 plus AQ plus 2E plus H2 gas, right? This is the way we can write, okay? Then you can see here both sides electrons are present. You can cancel them. You can cancel them. Then what is the final one? You can write here zinc solid plus 2 H plus arrow zinc 2 plus AQ plus H2. So H2 gas bubbles were liberated. What was the remaining ions inside there? Zinc 2 plus, that is remaining, and sulfate ions, that is remaining. Then what was the final solution inside there? Zinc sulfate was the final solution after happening every reactions inside the cell, right? So that is the thing you should know in this one, right? Okay. So understand the thing here, the thing happened here. So note down this, right? Very easy. Just the observation, if you can aware, right? You can take the full idea of that, right? Not very much hard, right? So you should know the observations clearly. You should know the observations properly. Then you can have a very good idea, right? Okay. So children, right? If you have noted this, right? I'll erase the board, right? So next I'll write this again. So you should remember this figure. If you have noted down, it's okay. Otherwise, you can take the previous part of the video and see it again, because I need the entire board. That's what I'll erase this, right? Now another special point I want to tell you. There are four words. One is oxidation. Other one is reduction. Other one is anode. Other one is cathode. These four words are very important, my dear children. Oxidation, reduction, anode and cathode. Right, now let's discuss what are those things. Okay, so children, for your further awareness, here I have drawn the picture again, right? No problem, right? So now you should help me right now. What were the reactions we observed? First one was zinc electrode was dissolved, right? That was the first one. Zinc electrode was dissolved, right? So what was the reaction through that? Zinc solid became zinc 2 plus AQ plus 2 electrons. That was the first one. Children, this reaction was occurred near where? This reaction was occurred near where? You could see here the zinc electrode was gradually dissolved and became like this, right? So I'm asking, this reaction was happened near where? Near zinc electrode, isn't it? Zinc electrode was dissolved, no? So that's why this was the reaction happened near where? Near where? Zinc electrode, right? Okay, now I have a question. Please analyze the reaction properly, right? Please analyze the reaction properly. This is what kind of a reaction? Can you see in this reaction releasing electrons or obtaining electrons? Once I told you, you can clearly understand. You will say, sir, zinc electrons, zinc atoms, they kept their electrons inside the electrode and they went to the solution. That means zinc atoms, they removed 2 electrons per each one and they became zinc 2 plus and they went to the solution. That was thing happened there. You will tell like this if you are very good of this, right? So that's what thing happened. That means here what was happened? Electrons were released. Electrons were released, right? So if we consider the first equation, what was happened there? Electrons were released. Electrons were released means what kind of a reaction was happened there? That kind of a reaction was known as oxidation reaction. What do you mean by oxidation? Can you please define oxidation with 2 words? Oxidation means what? Removing electrons, releasing electrons. That was known as oxidation. So oxidation reaction is this, right? Here zinc atoms, they released 2 electrons and they converted zinc 2 plus ion. So electrons were released. Electrons were released means what kind of a reaction is that? It is an oxidation reaction. Now did you get the point? What was oxidation reaction? Oxidation reaction means when the electrons were released from the atom, that was known as oxidation. Can you define oxidation with 2 words? Releasing electrons. Very easy, right? So children, first reaction regarding zinc dissolvement, it was known as what? Oxidation reaction. It was an oxidation reaction, right? Second one, I'll write the second reaction here with you. What was the second reaction? The 2H plus ions which was inside the solution, they came near to the copper. Why? There were electrons with the copper. Whose electrons? Zinc one. Zinc's electrons were with copper with you. Why? Because electrons were transported from zinc to copper, right? When electrons were overloaded, right? Then 2H plus ions, they took 2 electrons from where? From copper, right? And they made what? H2 gas. That's what we saw the observation. H2 gas, hydrogen gas bubbles were liberated, right? Gas bubbles were liberated, right? So my dear children, can you please tell something about the second reaction I have written here regarding 2H plus, 2H plus, 2 electrons, H2. What can you say about this reaction? Now you could see, you could tell here first reaction regarding this one, zinc, 2 electrons were taken and became zinc 2 plus after releasing 2 electrons. So electrons were released. It's okay. Electrons were removed. Electrons were released. That was known as oxidation. Well, now we are shifting to second one. 2 H plus ions, they went to near to copper electrode and they took 2 electrons and they converted to H2, hydrogen gas. What is this reaction? What can you say about this reaction? My dear children, what was happened? Electrons were released or electrons were obtained? Electrons were gained. Electrons were obtained. You can explain here. Here 2H plus came and took electrons. Taking means obtaining, gaining, right? So what is the second reaction? Electrons were obtained. Electrons were obtained, right? So second reaction can be identified as electrons were obtained, electrons were gained. So children, this kind of a reaction is described as reduction reaction. Reduction, right? Reduction. What do you mean by reduction? Reduction means obtaining electrons, right? If you are supposed to tell what is reaction of oxidation, your answer should be releasing electrons, removing electrons. If you are needed to tell what is reduction reaction, what is reduction, your answer should be obtaining electrons. So can you please take the difference of this? Can you distinguish these two properly? Very good. Well, right? So children, this is known as oxidation, this is known as reduction. So can you please tell what is oxidation reaction? This one. What is reduction reaction? This one. How did I tell this is a reaction of oxidation? Because electrons were released here. How can we tell this one as electrons were obtained? How can we tell this one electrons were obtained? How can we tell this one as a reaction of reduction? Because electrons were obtained. Understand what I say? Yes. Right? So now you know, my dear children, what is oxidation, what is reduction. Another two remaining, what? Anode and cathode, right? I'll advise you children, sometimes you are trying to decide anode and cathode after seeing the terminals of the battery by taking positive or negative in next part, right? I think that will be dangerous for you when you are doing for your examination. So always try to go through the way I'm talking here, right? Okay. Now you know oxidation. What is oxidation? Releasing electrons. What was the reaction of oxidation? Zinc 2 plus 2 electrons. What is reduction? Obtaining electrons, gaining electrons. What is the reaction of reduction here? 2H plus 2 electrons, H2. Very good, right? Now, what is anode? Remember, my dear children, right, this definition is very important. It's better if you can write this, right? I'll tell the definition slowly. If you need it, you can just write it. This is anode, right? Inside a cell, the place where oxidation reaction is occurred is known as anode. I'll repeat it. The place where oxidation reaction, right, is occurred, known as anode. The place where oxidation reaction is occurred is known as anode. The place where oxidation reaction is occurred, known as anode. Can you understand what I say? The place where oxidation reaction is occurred, that is known as anode, right? What is the oxidation reaction here? This one. What is oxidation? Releasing electrons. What was the oxidation reaction? This one. Where this was happened? Where this was occurred? Near zinc electrode, isn't it? Zinc electrode was dissolved, right? That is the reaction we are writing here to tell that zinc electrode was dissolved. Zinc 2 plus 2 electrodes. This reaction was happened where? Near zinc. That's what zinc electrode was dissolved. No? What is oxidation? Releasing electrons, removing electrons. What is anode? The place where oxidation reaction is occurred. Where oxidation reaction was occurred? Near zinc electrode. Near zinc electrode, right? The place where oxidation reaction is occurred, that is known as anode. That's why zinc electrode is known as anode, right? So this is the point, oxyanode. This is the point you should understand, right? A trick, a strategy, right? The students in my classes in school, they know my tricks, right, to remember these important points, right? So we are giving those things for you. We are not going to take them inside to our mind and just keep them as secret. No, children, right? Knowledge is with us to share, not to keep as secrets, right? So that's what I'm giving you. This is the point. Oxyanode, right? Oxyanode. What do you mean by oxyanode? Oxidation reaction. The place where it is happened, it is known as anode. Oxidation reaction. It was happened near zinc. It was known as anode. So you can tell the next one, cathode, right? Cathode. I'll tell the same definition. You can write or you can just memorize it. The place where reduction reaction was happened. The place where reduction reaction was happened is known as what? Cathode. The place or the electrode, where reduction reaction is occurred, known as cathode, right? So that is known as cathode, right? So children, what was the reduction reaction here? This one, no? H plus, they took 2 electrons and made H2 gas. That's what gas bubbles were liberated. That was happened here. These are the gas bubbles were liberated. That was happened near where? Near the cathode, near the copper rod, right? Sorry, this is not copper. This is an iron, according to the question. Copper is also possible, no problem. Near iron rod, right? So what happened? You know the process right now. Electrons, those who were in zinc electrode, they shifted to the connective wire and they passed from zinc to iron. So that's what now zinc electrons were in iron rod right now, right? So 2H plus came to take electrons from iron to make H2, right? So where they took electrons? Near iron rod, iron electrode. So that is known as cathode. What is cathode? The place where reduction reaction is occurred. What is reduction reaction? This one is reduction reaction. The place where reduction is occurred is known as cathode, right? So you know right now what is anode, what is cathode, what is oxidation, what is reduction, right? Red cathode, the trick, red cathode, oxyanode, red cathode, oxyanode, red cathode, right? They keep those tricks with you right now. Oxidation process, the place where oxidation process was happened, the place where oxidation reaction was happened is known as anode. The place where reduction process is happened, that is known as cathode, right? Oxidation, anode, reduction. Oxidation, anode, reduction, cathode. The place where oxidation reaction is happened, it is known as anode. The place where reduction is happened, it is known as cathode. Understand? Very good. Right. Now see the question. From the above two cells A and B. Now children, you should have this knowledge, otherwise you can't write the answer for this question, isn't it? Right. From the above two cells A and B, which is the electrolytic cell, it is B. Still I didn't explain what is that. Right. One observation that could be obtained when the A cell operates. I have given you two observations. Hey, don't write regarding the ammeter one, because ammeter is not there. So you can't write ammeters, indicator was rotated. No, because that is ammeter is not contained here, right? So what was the two observations? One is zinc electrode dissolved. That was the first one. You know the reason for it right now, right? That was the first observation. Second one, gas bubbles. Don't write hydrogen gas bubbles because we don't know. First we are seeing the observation. No, so you just mentioned those are gas bubbles, right? You can tell gas bubbles were liberated. Gas bubbles were liberated near where? Near where? Near iron electrode. That was the perfect answer you should write. Okay, my dear children. So you are supposed to write only one. Write one observation that could be obtained when the A cell operates. Right? You can write zinc electrode dissolved, or you can write gas bubbles were liberated near iron. Right? Whatever the answer you are writing, right? It is accepted, right? Okay. So you need to take the answer for part 3, right? With the knowledge of electrolytic cells, right? Okay. Now come to the part B, right? Have you finished regarding this? So what is anode reaction here? This one. What is cathode reaction here? This one. How can I tell at once this is anode reaction? Because this is belongs to anode. This was happened. This is an oxidation reaction. Oxidation is anode. The place where oxidation was happened is known as anode. This was happened near zinc. So zinc was anode. This is the cathodic reaction. Cathode reaction. How did I tell at once this is a cathode reaction? Because this reaction is occurred near iron, right? So this is a reaction of reduction. Reduction means obtaining electrons. This was happened near iron. That's why it is described as reduction. So this already reaction is happened near iron. That's what it is known as cathode. So this is the cathodic reaction, right? These are the points you should know. Again, if you can watch this, you will understand, right? Try to understand first time, because I have clearly explained for you without any right objections. Okay, right. So let's come to the other one, children. Other one is easier than this. Okay, actually the entire lesson is easier. Don't think it is much hard, right? But you need the previous chemistry knowledge. No, you need the knowledge of making ions, and you need the simple identification of zinc and iron, right? Those things. Otherwise, you can't go through this. That's what. No, consequently, the lessons were already established in your syllabus. Otherwise, if all the lessons were jumbled, you can't go through. No, that's what you need, the awareness of the previous lessons, especially in previous chemistry parts. Otherwise, you can take the proper answer for these things, right? Okay, well, second one, right? Right, as we have did previously. Again, I'm drawing a container here like this, right? And I'm putting two carbon rods, carbon, carbon, and externally I am giving a power battery supply was given there, right? And a special solution was put inside the container, right? So children, what can you say about carbon, right? Once I write the important things, you should remember as the way I taught you. What is carbon? What are the things you know about carbon? Please explain them first. What are things you know about carbon? Carbon is the sixth element of periodic table, right? So electronic configuration of carbon is 2, 4. Second energy level, 8 electrons can be added, but already 4 electrons are completed, 4 is remaining. 4 electrons were not completed. So children, carbon is, we can't tell carbon as a metal, right? Carbon is normally considered as non-metal, but children, carbon can show some metallic qualities, right? Can you remember about allotropic forms of carbon? Allotropic. Allotropic means carbon can stay different ways naturally. There are two allotropic ways of carbon. One is graphite, other one is diamond. So here, what is here? Diamond. No, right? It is graphite, right? Graphite rods. Now we have mentioned here as carbon, but remember, not carbon, they are graphite, right? Graphite is also carbon. So you know, in the point of the pencil, graphite rod is there, no? So likewise here also, those are graphite, right? So diamond, if we put there, right? So if we can use the diamond rods in a school lab, right? Next day the lab assistant will come with a Prado or some kind of a luxury vehicle, right? Why? Diamond is very much expensive, right? So these kind of situations we can't use diamond. Okay, right? Graphite, so allotropic, right? So graphite is you know, they are conducting electrons, sorry, they are conducting electricity. So some metallic features also can be seen in carbon. So children, other thing is, now if we consider about the second energy level of carbon, it is partially completed. Partially means half, right? So that's why sometimes carbon, normally the thing is, children, carbon is trying to obtain 4 electrons and complete its energy level. Sometimes if the carbon try, they can release these 4 electrons and keep the first energy level, right? That is the way of difference of it, right? Because carbon is half completed one, no, half stable one, right? So that's what. Okay, just keep that in your mind. So these are the allotropic forms of carbon, graphite and diamond, right? So in A levels you will study about other one like fullerene, right? So now think about that. Now you should know graphite and diamond as the allotropic forms of carbon, right? So what we are putting here, graphite rods, right? So we are mentioning here they are as carbon electrodes, right? So as we are giving that energy right now, right, maybe a 9 volt or some kind of volt energy we are giving there, right? So children, first of all, we should name these carbon because both are carbon, no? So first I'll write this as A and B, okay, but it is not possible, it is not necessary. We should name it as positive or negative, because in a dry cell also positive terminal is there and negative terminal is there. Likewise, we should name this carbon electron belongs to which terminal, this carbon electrons belongs to which terminal, that is needed, right? So children, this carbon electrode, please see, first I'll name, this is the positive terminal of the cell, this is the negative terminal of the power pack, this is the positive one, negative one, right? So now see the board with my marker pen. Here this connective wire is connected to the which terminal of the dry cell? Plus terminal, positive terminal, no? So that's why this A1 is automatically becoming positive carbon rod. So if that is positive, other one should be definitely negative. But you can see here, this wire is connected to the negative terminal. So that's why it is almost becoming negative, right? So that is the way we can take, this is positive one, this is negative one. What is the solution? What is the solution? Fused. So we can tell this as molten sodium chloride. What do you mean by fused or molten sodium chloride? So children, sodium chloride is an ionic bond, right? Sodium and chlorine, they are making a proper strong ionic bond and they are making sodium chloride. So we are aware of it as a common salt which is used in our home, right? So that is made with sodium chloride. If you are supposed to make a sodium chloride aqueous solution, it's too easy, right? What's the way you should do? Just take sodium chloride and put water inside there and just stir it and just sodium chloride aqueous solution. It's enough, right? Then you are supposed to make a fused or molten sodium chloride. Then what will happen? Children, this is the thing you should do. You should take the sample or the crystals of sodium chloride and you should give a higher temperature for that and you should heat it, right? When you heat that, it is reaching to its boiling point and what happens? It is becoming a liquid. It is known as sodium chloride liquid. We have not put at least a drop of water, right? So if we have put a drop of water or something water, it is becoming aqueous solution, no? But this is a molten or fused, it means simple thing, we should heat it. When it is heated, right, it is becoming a liquid, right? So what's the way we can write it? NaCl liquid, NaCl liquid, right? NaCl, sodium chloride liquid, like this. This is the way we can write the fused or molten sodium chloride. Children, I'll tell you something. Be happy if you see this kind of a question. Molten or fused sodium chloride. Why? It's easy, right? Inside molten or fused sodium chloride, right? Inside the molten or fused sodium chloride solution, only sodium plus liquid ion and chlorine minus liquid ions are present because no water is added, no, right? This is not an aqueous solution. But if that is aqueous solution, you should consider water inside there, right? Like this, H2O liquid, right? H plus AQ and OH minus AQ. This one also should be considered if this is an aqueous solution, right? But no problem, this is not aqueous, this is a fused one, right? So it's easy. Question must be very easy rather than previous one, right? Okay, just only consider this one. Actually, that's what I told you, this one is easier than the previous one, right? Okay, now see what happens, my dear children. This is very funny, right? So funny things are happening in science as well, right? Now what are the ions inside there? Sodium plus liquid is there, chlorine minus liquid is there. Now what is happening? Now children, sodium is a plus ion, right? Sodium is a plus ion, right? Sodium is trying to go to its negative terminal. So tell me, my dear children, what is the negative terminal for plus 1? Or what is the opposite terminal for plus 1? Negative. Negative. Opposite one of plus is negative. Then, right, sodium is trying to go to negative terminal of carbon rod, right? Negative terminal of carbon rod. Then what is happening, my dear children? What is happening? Sodium plus liquid, they are, right, now sodium plus, no, just one plus, so it is taking one electron and becoming sodium liquid. Sodium layer is applied, you can see as the observation near, surrounded with B electrode, right? So children, what is happened actually? Sodium plus iron is reaching to B, right? This is negative, no, right? So actually negative means children electrons are already filled than the previous one, this one, right? So sodium is requesting, can I have electron with you please? Then I can make sodium layer with you, I can become sodium atoms. So what is happen? So carbon can do both, I told you here. Carbon, normally carbon is waiting for obtain electrons, but carbon can release the electrons as well. It is happen not in everywhere, right? So here sodium is requesting one electron and sodium is taking one electron from this carbon rod, negative one, and becoming sodium plus, right? Now keep something I told you previously. Reduction and observation. Can you remember? What do you mean by reduction? Obtaining electrons. What do you mean by oxidation? Releasing electrons. What kind of a thing happened here? Sodium plus has taken one electron from B. Obtain electron from B. That means what is this? It is a reduction. That's what I told you to remember the previous words, my dear children. This is reduction. Right. Next one. Chlorine. Now tell. Cl minus, no? Cl minus ne. Cl minus is going to opposite one of Cl minus. What is the opposite of minus? Plus. Who is the plus? This plus carbon electrode. Okay, right? But there's a problem. Why? So children, chlorine is making chlorine gas, no? So you know chlorine gas is not happened as a unique atom, right? Only three gases in helium, neon, argon in our periodic table, they are very independent and they are just having only one atom and staying as gaseous state. But other every atoms can't do like that. If they need to be the state of gas, they should take other the same one with him, right? So chlorine also can't do, children. If chlorine is Cl2, no, so only one Cl minus is here. That's what chlorine is asking from other chlorine to go with them, and 2Cl is going to request, or what? 2Cl minus ions are going to carbon this one plus. Then what they are doing? They have both electrons, right? They are releasing those electrons to this positive carbon rod, and they are making Cl2 gas, right, by releasing 2 electrons, right? Cl2 gas by releasing 2 electrons. Those 2 electrons were taken by this carbon, right? So that's the interconnection between carbon and other atoms, right? Other ions, right? Okay, what chlorine did? Now tell me. Chlorine was like Cl minus. It is 1. So with alone, right, chlorine can't become Cl2, no? So that's what chlorine is taking another Cl minus. Actually, that's the way it is happened, right? And because lots of chlorine ions are inside there, right? So that's what, okay? So children, when we are doing that, right, without thinking it, when we are balancing it, we can think and just put 2, but it's okay. We can understand the way that we have done here. 2Cl minus ions, they are going and they are giving the electrons to this carbon electrode, and what happens? Making Cl2 and releasing 2 electrons. So children, now please tell, this is what kind of a reaction? 2 reactions we know, oxidation and reduction. We identified the first one, reduction. Sodium plus, they requested only one. Requested means taken, it means reduction. So here 2Cl minus released 2 electrons and became Cl2. Released. It means oxidation, right? This is oxidation. Now I am again coming to anode and cathode. Can you please define what is anode? The place where oxidation reaction was happened. Every time regarding the place, don't take positive negative, right? It's maybe wrong, right? The place where oxidation, can remember the trick, oxyanode. What is the oxidation reaction? This one, right? This one is the oxidation reaction, right? This oxidation reaction was happened near where? Chlorine went to where? A carbon electrode or positive carbon electrode. Then for positive carbon electrode is what? Anode. Here sodium plus went to negative carbon electrode to take electrons, and this reaction was happened near it with, right? So this one is what? Cathode. Can you remember? Oxyanode, red cathode, reduction cathode, right? So what is anode reaction? This one. What is cathode reaction? This one, right? So you can take the final reaction of it, my dear children. Just take 1 plus 2. Then you will tell this reduction reaction just having only 1 electron, but second one is having 2 electrons. Then what you should do? Just multiply first one by 2, and then you can see here the electrons are equal with each other. Then just cancel it off and write the final one. Simple mathematical part is also there, right? Okay. Can you do that, or shall I do that? Can you do that, or shall I do that? Okay. Now see, like this. Here, take these two separately. Sodium plus liquid electron, 2Cl minus liquid arrow, Cl2 gas plus 2 electrons plus this one sodium liquid, right? Then you should, it's better if you can multiply this one by 2, right? Then what happens? Everyone should be multiplied by 2. 2 sodium plus, right? Then 2 electrons, then 2Cl minus. 2Cl minus is below this one, no, right? So that's what you should consider, only first one, right? Only first one, right? So 2 sodium, right? So this first one should be multiplied by 2. Then electrons were multiplied by 2 and both were equal, right? Then 2 electron cancelled. Then you can take the final one here, my dear children. 2 sodium plus liquid plus 2 Cl minus liquid, Cl2 gas plus 2 sodium liquid. What was the observation, my dear children? You can see a gas, you can see the gas bubbles were liberated. Actually, what is the gas made here? Cl2. Where it was happened? Cl2 went to where? A. Near A carbon rod, you can see here gas bubbles were liberated, and sodium atom layer was made, that was deposited around the B carbon rod. Normally carbon is known as a black colored, graphite is something like slightly black colored rod, sodium is a silver colored layer. You can see a silver colored sodium layer was applied surrounded by around the B1. Those were the two observations you can see here, right? So with the electricity you did some kind of a change of the solution, no? Previously with the help of the solution and everything you generated electricity. Previous cell we have discussed. Those were the two things inside electrochemistry. Understand? So again and again, if you can watch this, it's good, right? 4 words. Please tell with me. Repeat with me. What do you mean by reduction? Reduction. Releasing electrons. Wrong. Reduction. obtaining electrons. Oxidation, releasing electrons. Oxy anode, the place where oxidation is happened, it is known as anode. Place means the electrode, right? The place where reduction is happened, it is known as cathode. Very good. 2018 also this kind of a question was there, my dear children. Please do that. Write the cathodic reaction of that takes place in cell B. What is the cathodic reaction? Reduction is the cathode. Reduction reaction is known as the cathodic reaction. Why? Red cathode, reduction cathode. So this one is the answer. You can write. What is the name commonly given to the electrodes where oxidation reaction taken place in both cell? Oxidation, the place. That's what. Can you see the questions are coming according to my answers, according to my points? The place where oxidation reaction is occurred, it is known as what? Anode. So in previous one also, the place where oxidation is occurred, that is known as anode. Here also the place where oxidation process was occurred, it is known as anode, right? Next one you can think and write. What is the reason for not using cell B in the production of sodium metal industrially? Right? There was a special apparatus for making sodium metal. It is known as down cell, right? It was also there in your syllabus, right? But we can't expect from that one in this O-level examination. So in this time also sodium is made. Can you see? But children, this is not used in industrially, right? What can you say? Why? One thing is, children, now this is a little apparatus, no? So that's why we can't make a proper metal inside there. That was not the important one, right? So children, when we do this reaction, right, when these are dissociated, again children, sometimes this sodium plus and this chlorine minus be added again and making sodium chloride. Without making sodium liquid like this, then do we need sodium chloride again? No, right? So that was a disadvantage, right? So that maybe happen. So that's what this is not used in industrially. Understand what I say, right? So that is very, very important for you, right? So children, I think I have today explained for you the very important things regarding electrochemistry, right? So please understand what I say, right? I know all of you can understand this very simply. With every theories, see the board is something like graphitos in C, right? Everything I have mentioned here, right? Please watch this video twice or thrice, then you will clearly understand, right? So the entire lesson was completed, right? No other theories to be done, right? Entire lesson you should know: reduction, oxidation, anode, then cathode, right? Reduction, releasing electrons. Releasing, reduction, obtaining electrons. Oxidation, releasing electrons. Anode, the place where oxidation happened, right? Oxyanode, right? And cathode, the place where reduction happened, right? So that things will be important, right? So children, we can expect another final video for you before your O-level examination. As you all know, 29th of May, your O-level examination will be held. So I think all of you are ready with your O-level examination, and I wish you all the very best for your O-level examination. I know you can win, right? You all are get ready. You should ready with your level examination with you right now. I know all of you can win. So please win this game, right? All are waiting to see your results, not even me, right? So you should win this game. I know you can win this game, and I wish you all the very best to win this game and show your maximum strength, right? So see you in next video. Have a good day and see you everyone. Please subscribe our YouTube channel and keep in touch with new videos. See you. Bye.